we are going to learn how to apply the differentiation rule for simple expressions. Before we start, let's revise what f prime x means. F prime of x is the notation that we use for the gradient of a tangent to a line. It also represents the gradient of the function of f. It's also the same notation for the instantaneous rate of change, or just the rate of change. And it is also the notation for the derivative of the function of f at any point. For the next few lessons, we will only speak about the derivative, but know that it can be any of these. It's all the same principle, and it's all represented in f prime x. Also, over the next 4 lessons, we are going to use different notations at different times. So we have f prime x, that is the same as dy dx, and that's also the same as dx. These 3 notations all represent the derivative of the function. In the previous lesson, we have learned how to find the derivative using first principles, meaning applying a limit of h towards 0 and then working with this equation. And this is called finding the derivative from first principles. But there are simpler ways, and we are now going to use a rule instead of this formula. So let us say I have a function of fx is equals to x to the power of n. The rule says that to find the derivative, I multiply the value in front of x with the exponent, and I simply subtract 1 from the exponent. So in order to find the derivative of fx, where fx is equals to 4x to the power of 5, I'm going to multiply the exponent of 5 with the 4 and subtract 1 from the exponent. So the derivative is 4 times 5, x to the power of 5 minus 1. As you get more confident, you would learn that you can skip this step. But let's use it for now so that we can see what we are doing. So if I simplify, I have 20x to the power of 4. Now let us move on to a different notation. Here we have y is equals to 10x to the power of 1. And notice we're no longer using fx but y. So therefore, the notation for the derivative is dy over dx. But the rule stays the same. So I multiply the exponent of 1 with the value in the front, and I subtract 1 from the exponent. So this will be then 10 times x to the power of 0. And x to the power of 0 is 1. So the derivative of y is equals to 10x is 10. In our next example, we have y is equals to negative 8. Notice there is no x value. So the derivative is 0. You can also see it in this way. Y is equals to negative 8 times x to the power of 0. And now I have 8 times 0 for the derivative, which is 0. If you find this too complicated, simply remember, if there is no variable, there is nothing to differentiate. Now, let us use a different notation. So we have dx is equals to 4x squared, and we want to differentiate 4x squared. We apply the same rule. So it's 4 times the exponent of 2, and then in the exponent 2 minus 1. Notice we don't have a notation of f prime x or dy dx on the left. We are simply differentiating this expression, and therefore it's all equal. Now, let us move on to a fraction. I'm going to show you 2 ways on how to differentiate a fraction. First, we can rewrite x to the power of 4 over 8 as 1 over 8 times x to the power of 4. And to find the first derivative, I multiply 1 over 8 with the exponent of 4, and I subtract 1 from the exponent. 4 over 8 will give me a half, and then simplifying the exponent is x to the power of 3. You can also write it as x to the power of 3 over 2. Now, let's use that same example, but this time we are going to use a different notation and follow a slightly shorter path. So I have x to the power of 4 over 8. I can simply multiply x with 4 in the front and subtract 1 from the exponent. 4 over 8 will give me a half, and the exponent simplify to x to the power of 3.